Okay, let's talk a little bit about compiling a program. So this is the basic idea. When you write a program as a programmer, you write it in a particular programming language. We'll use C++. There are many other languages available. But most of those languages, they're known as high-level languages, are not actually things that the computer can understand or follow. They're they're much more built for the programmer. But they're also something that the programmer has to work a lot to get right. You can't just write anything you want down. You have to write things in the language very specifically. So you write things in, say, C++, and then that somehow has to be translated into a language that the computer can follow. Now, for every computer, based on its chip and its design, it has a machine language that works for it. It's the language of the machine. And that stuff it can follow. That stuff it can, those programs it can follow. So you need to translate the original C++ code into machine code, machine language. And that translation would take forever if it was done by hand. But the good news is, if you have a programming language, there will also be available somewhere a compiler or a program, another program that actually translates your programs into machine language for a particular type of computer. So in this case, I just want to show you how this works. On the left-hand side, I have something called Visual Studio. Now, compilers come in a variety of shapes and sizes. Many of them are free. Some of them cost something. We're using something called Visual Studio, which does cost something, but the school already buys it. So that's what we're going to use. You have access to it, and you can download it for free. I will talk to you more about that next semester when you're actually doing programming on a computer. I mean, you're doing it now. You're just not doing it on the computer. And if you want to know more, you can contact me aside from that, and I can maybe show you. But so we're going to be using Visual Studio at SOC, and you can use that at home because you can download it for free as a student at SOC. You're allowed to do that. If you're not a student, you have to pay big bucks for it. Their idea, by the way, why is it free? Microsoft makes it free for students because if they can hook you on using their compiler, then they know when you get into jobs where you actually control the budgets and decide what compiler that job will use, you're more likely to recommend them. So they are willing to give it to you for free as a student if they can count on you're recommending it when you have a company that will spend big bucks to purchase it. So that's why it's worth it to them to do that. Now, Visual Studio is actually not just a compiler for C++. It's what's called an Integrated Development Environment, an IDE. IDEs are the common thing right now. And the IDE is several different things. First of all, this particular IDE, as is true of many, actually is not just a compiler for C++, but for about 5 different languages. So you can use Visual Studio for C++ or Java, for example, or F#, or I think it's called, or C#, which is a parallel C, and many other versions of things, and they're all available through Visual Studio. We're only going to use ours, and Visual Basic, we're only going to use ours with C++. All right. Secondly, they don't just have a compiler. They have many other tools that are helpful. For example, they have special debugging tools that let you check quickly find errors in your code. They have all sorts of other special tools that are useful. One of the most important tools is they have an editor. That is, rather than write your program separately in a text file somewhere and then telling the compiler to compile it, they have you go in and write the program directly in the IDE, and they color code everything so you can tell how everything works. So what we're going to do here is open up the editor, write a C++ program to do something, compile it, and then run it, and you can sort of see how it all works. And along the line, we'll be using about 5 or 6 different capabilities of the IDE, but the most important one is the compiler. And a lot of times people will still just call this the compiler, even though it's really a compiler plus a lot of other things. So I've opened up Visual Studio. I'll explain how to use this next year when you're using it. But for right now, let me just go to File, New, Project. Sorry, this is taking a while because I just opened it up. I will use a Windows Desktop Wizard. I haven't run this for a while on my computer, my laptop, and it may be taking it a while to get things working here. So you have to be patient. Empty project. We'll talk about all this next semester. The whole point is that I'm just setting this up to let myself write a program. Very short, simple program. This might be slow also because I'm busy running the the recording software at the same time. Okay. Here we have what's called a solution, and in that we have what's called a project, and in that we will create something called a source file. So you don't have to worry about this till next semester, but this is all, again, sort of overhead. It's part of the IDE. The IDE allows me to create source files, which is where I put the files that I write my program in. But it lets me have something called a project. That's like the program as a whole. The reason it does that is sometimes for complicated programs, you actually have several different files, and you combine them all to make a single program. For now, we're just going to have one file. And then it lets you put those in solutions, which are collections of programs. And we don't need any of that for now. I'm just going to come to source file, right-click and say add, new item. And I'm going to pick a CPP file, which is C++ file. I'm going to give it the name example for CIS 150. Okay, so here it is over here, and then over here on the left is the editing window. Here's where I'm actually going to write the whole thing. I'm going to shrink this over here so it's auto-hide it. I'll bring it back later. Here is my program when I want to write it. So let me just write a simple program that will do nothing really amazing. It will actually, I suppose I'll have it add two numbers and print out the result. So this is not going to make me a million bucks anywhere, but it's simply going to say, type in two numbers, and you'll type in like 3 and 5, and it'll say 3 plus 5 is 8. So here's the way I'll do it. Now I'm going to write a lot. There's a ton I won't explain here. I just want you to see it. In most C++ programs, you start by putting these statements in here. Let me just write it for a little bit, and then I'll talk about what I've written. Actually, let's stop right there. Most of this we'll talk about next semester. Include IOStream. Hold on. I take it back. Let me just write this. You can see what I'm writing, and then I'll talk about it all in just a minute. Okay, so I'll type everything in here. Okay, let's talk about what's here. You'll see everything's color-coded. The green stuff up here starts with 2 slashes. It's known as a comment. You can put comments in a program, and basically the comments are completely stripped out when it's translated. They never make any difference to the program at all. You put those there for people. Any person who comes back and looks at this program will see in the comments what the program's for and what it's about. When you actually write programs in the next semester, you'll always include a comment at the top that gives your name and what the program does. And you'll also put some comments sometimes in the middle of the program wherever there's something tricky happening, so that as I'm reading your program, I can tell what it does. This is part of good software design. If you go back to modify a program and you find comments in the code that tell you what everything is for, then you don't mess things up that you didn't know about. You don't mix things up as you're trying to understand what's going on. And it's also a lot quicker, because if you're trying to, say, find the part that fix the part that maybe prints and you need something fixed there, you can go find the part of the code that says this is what prints, and you know that's the only part you really need to look at. So good commenting is actually a part of the art of good programming. Now down here, these two parts are something you have to do in C++ and in a few other languages, but normally wouldn't be a main part of the program. C++ is built so that it sort of natively doesn't include all the capabilities you'd normally want for it. It doesn't include, for example, input and output capabilities normally. What you have to do is pick the library that you want to include, and it includes an extra library of capabilities that it can use. And IOStream stands for input-output stream, and that include statement says, include with this program all the stuff you need for input and output. And namespace, the namespace standard is similar. That's not STD, it's standard. The namespace standard, you're saying use the names that have already been defined for input and output, among other things. And this down here, this thing that says COUT, that's pronounced cout. This thing that says CIN, that's usually pronounced CN. And some of these other symbols, those are all defined in the library and in that namespace. So it's adding those things that gives me input and output capabilities. If I wanted to use different libraries, I could get a different set of input and output capabilities. With enough work, I could even get something that gave me a graphical interface, so you could use the mouse and other kinds of things like that. But I didn't do that here. All right, right here, int main. Every program in C++ has to have a main, has to have a portion that is called main, and it has to be spelled M-A-I-N, all lowercase. And if you don't have that, the program won't run. What happens is your C++ program is built out of a lot of subprograms. In other words, one program can actually call another program to do, another smaller program to do parts of the work for it, and then that can call other smaller programs. That ability to write programs that call other programs leads to something called modular programming. It's, again, a very important part of making your programs maintainable. If something's modular, it means it's sort of got pieces that you can pull out and insert something else instead and know that the whole will still work. It gives you sort of interchangeable parts when you write the program. In this case, it's not very modular. We've only got a single subprogram, and it's this one called main. There always has to be one called main in C++. And that's what this top thing is saying. It's saying that we're calling this main, and the parentheses are used for stuff we'll talk about halfway through the semester, and this int is used for stuff we'll talk about halfway through the semester, and this bracket from here down to here says that's where main is. It's everything inside that. Inside main, we have a bunch of stuff going on. The first thing we have going on is what's called a variable declaration. This just sort of announces what variables we're going to be using for the program. Every program tends to use, or every normal programming language uses variables, where a variable is like a container or a box that holds the values you need. Think of it as anything that you need to hold temporary results as you go. So here what we do is we're going to ask the user to enter two numbers, and he's going to store one. We're going to store one of them in I to hold on to it, and one of them in J to hold on to it, and then we're going to add them together and store that in sum and hold on to that, and then finally we'll print them all out. So we'll have temporary variables or holding places for all the different values we have. And that's what this does. It just announces what the variables are that we're going to be using. I and J and sum. And they're all integers. That is, we expect these variables to hold numbers without any decimal part to them. So we'll have our own variables in class, even though we're not using C++. Our variables will primarily be either numeric variables or string variables. And you'll see either num instead of int or string instead of int. And the num variables will hold numbers, whether they have decimal parts or not. And the string variables will hold text, like addresses and names and things like that. Okay, down below, now that we've defined these variables, we come down and do the rest of the code. I left some blank spaces here. That's perfectly fine. I can put blank spaces wherever I want. And I tended to put one statement per line. Most languages build things in terms of statements. You have a statement which does something, you have another statement that does something, you have another statement that does something. It's typical to put those on separate lines. And then the important thing is that a program goes in order. It does this, and then it does that, and then it does that, and then it does that, and then it does that. It doesn't jump around. So that's one of the things just to remember. We'll get to it later on. So this first statement simply prints on the screen, enter two integers. The second statement takes whatever the user types in and puts them into the variables I and j. The third statement calculates sum by adding I and j together. The fourth statement prints a bunch of things. It prints whatever the actual value of I was, then it prints the letter plus, the character plus, and then it prints whatever j was, and then it prints the actual equals character, and then it prints whatever sum was, and then it goes to the next line. That's what this endl does. And then we return 0. We'll talk about when we take C++, but that basically ends the program. All right, now let me do this. Let me first of all save it. Save. And I want to go show you where it is and what we have here. So let me go find I wonder if I have this somewhere. Hold on just a minute. I need to find out where this is so I can show it to you. Oh, project 3. Okay. So if I just use Windows Explorer on my computer, go look inside project 3, I can find something here. There's that file right there, example for CIS150.cpp. If I were to open this up using, just say Notepad or something, you can see, here it is. I didn't have to have the Visual Studio IDE to type this in. I could have opened up Notepad and typed it in that way. Oh, you can't see that. I think it's behind my picture. Let me move it over here. There it is. And I didn't need to have Visual Studio to type that. I could just type that using Notepad. You'll notice that this is not color-coded. The color coding came with with Visual Studio. But there it is. But if you try to run that on the computer, typically speaking, it won't have any idea how to run it because that stuff is not meaningful to the computer. So what I have to do is compile it. So let me compile this. One way to do that is to go to to build, and say compile. Matter of fact, let me go further than that. Let me do a slightly more complicated kind of compiling and say build. Let me just say build. I'm glossing over some things here. Okay, now what I want to show you is that if you come back here and go inside this debug folder, that's not what I wanted. Where is my folder file that I'm supposed to have? Oh, I see. I'm one too high. Okay, go inside this debug folder, and there it is. There's that project3.exe. That's the thing that I just, when I hit that, I translated this thing that I had before into machine language. Let me make sure it stays out of the way of my picture here. Let me show you what that looks like by opening it in, if it will let me do it. Let me go back to my Notepad. Hold on, you'll see this in a minute. Open. I'm going to go open what I just created using Notepad to show you what it looks like. It won't even let me do it at first. I'll say all files, go to project3.exe. When you open it, it looks like this. Gibberish. Now the reason it looks like gibberish is because this is machine code. It's not built to be interpreted by Notepad. Notepad has no idea what to do with the stuff in here. So it gives you guesses of what the characters are. And that's not really usable at all. But that's not what you're supposed to do with this. What you're supposed to do is run it. If you just click it, double click it, it will actually run. At least I believe it will. There it is. So you can see here it says enter two integers, and I put in 5 and 7, and it says, oops, it disappeared. It says 5 plus 7 is 12, but we didn't see it because it disappeared off the screen. Let me show you what it looks like in another way. I can also do all that from within the IDE. I can just say build, run. Actually, let me just do Control F5, which will do it. And you'll see the same thing right here. Enter two integers, 5 and 7. And you'll notice it says 5 plus 7 equals 12, and that's the program. The press any key to continue is not part of the program I wrote. It's simply something extra that the IDE sticks on the end. So when I ran it before, it actually did that too, but as soon as it was finished running, it cleared the window off the screen and didn't give me a chance to see it. So if that was a concern, I'd have to write some extra code in here to slow it down and make it wait until I was ready to go on. All right, I don't know if that made any sense, but let me clarify what I said by sort of reviewing it. My point was, when you write this, you get a C++ program in C++ code, and that's known as the source file. And then when you compile it and get the executable, you get the executable file. And that's the one that the computer actually runs. When you go to sell this to somebody, you sell them the executable file so that they don't have to worry about what the source file looks like. They don't see it at all. It, first of all, protects your programming because they can't go in and change it easily. But secondly, it means they can't accidentally go in and change it. They don't have to see it, worry about it at all. They just get this thing that they click and it runs. You have to sell them, you have to compile it for them into the right kind of thing. It also means they don't need a compiler to run it. So you need a compiler to run your programs in the first place, but once you've created executable files, you can give it to somebody else and they can just run it from the executable file as long as you compile it for the right kind of computer. All right, so I don't know if that makes any sense. Hopefully it does. The most important thing for now that I wanted you to see was a quick example of an actual program. In C++, we'll use that example a couple times as we go through the class. And also mainly the idea that when you write your programs in a programming language, and then it compiles them into something called executable code or machine language, which is runnable by the computer. That's all I need to say for now.